Alright, so here we will be talking about a way you can write your binary files a lot faster in a language like C++. You can probably adapt it to C also, considering. Uh, so we'll get down to what I mean by buffering. When I say buffering, okay, when you have an OS, your OS is what actually handles communication between your program and your hard drive. So every time you make a call to write to your hard drive, that's something your OS has to do. And the truth is, it's an expensive process. Okay. Usually, a lot of times when people have a bottleneck in the program, whether it's rendering with their video card, or if it's something like writing to the hard drive, as we'll be discussing here, or even just interacting with RAM. A lot of times when people experience bottlenecks, it's not that the hardware is being pushed to its limits, but it's actually that they are causing more communication to be between the hardware and your program than is necessary, okay? Because the thing you have to get used to with performance critical applications is that yes, processors nowadays are really fast, but your processor doesn't do a whole lot on its own typically, and that is why it's important if you do have performance concerns to to try to make things optimal. You know, you get a lot of work done, but try not have to be overly verbose in your program. And I don't mean writing more code. I mean, for example, if you're rendering something, you do try to do more batch drawing. Okay, you don't want to have to make a ton of draw calls or whatever equivalent is, whatever graphics library you're using. You know, probably if you've done something like that before, what you want to do is kind of more batch drawing. Well, it's the same way with file system input and output. Uh, what you want to do is do more like batch calls. Okay, so you want to try to minimize the amount of calls you have to make to actually write to your hard drive. So when I say buffering, that's really all I mean is you have an in-memory buffer that you actually write to. Okay, so you write to memory, and then so you write your data to buffers, and then you write your buffers to the hard drives. Is what I mean by that. Uh, so now I'll get on to why you should even bother with this. Okay, so the reason to bother with buffering is, well, chances are whatever you're developing, for a lot of people I've seen, you probably don't really need to worry about it. And I need to say this, that don't ever bother optimizing probably like heavily on something if you don't need it. I mean, at the same time, I don't think people should ever just be flat out wasteful and cause a bunch more system resources to be used than necessary. But at the same time, you don't need to be squeezing it like a you're trying to make a dry lemon if you don't need a situation. However, sometimes you need to have really fast file input and output. Sometimes you have an application that just writes and reads a lot of data. We're assuming we're working with binary format here. This isn't with text or anything like that. But I mean, I've had personal experience with it. Mostly for me, it's, well, for example, I have a game engine I develop, and it has to be able to read and write tile data chunks really fast because it's for open world streaming. So when the player moves around, it has to be able to deload chunks and then load back up the new ones in his area. And if it's not fast at this, then there's stuttering in the game and everything, and it doesn't feel smooth. Or sometimes you just have to work with a bunch of data, and you want to do it as fast as possible. Now, what I'm going to show you, I'm not going to say is the perfect way. It's just one method that can help you, and from my personal experience, it does help a ton. Typically, it's pretty helpful. Uh, but in reality, if you're not worried that much about it, it's not a big deal. It's not like you need to use it with everything. Again, if there's not a performance concern already, you probably don't need to worry about it. Alright, last thing before we get started, I'm going to give out some disclaimers. For one, how I'm going to show you to do this is by no means the way you're going to actually have to do it. I'm going to note for one, there are built-in features with the way C++ works that will let you do like buffering on your files, okay, and you probably just want to go with that. However, if I do that, it doesn't really show a ton about how it works, I guess, what I mean. So on this, I'm going to be more or less doing it in a way that's exposed more directly to you. It's not a big difference. Basically, I'll be showing you how to allocate and write to the buffer yourself. I'll be showing kind of how it could be in a real world situation, except for the fact that you probably wouldn't reinvent the wheel like this. Another thing is disclaimer, this method is going to require some guessing on exactly how you implement it, because, well, explaining how it works, when I said these buffers you write to them before you write to the disk, well, I should probably explain to you the deal with these buffers. See, the buffers have to have sizes, okay, and it's not like you just write to this giant buffer that's your entire file and then you dump that. Technically you could do that, but it's not the optimal way. You see, whatever computer you're using, and of course hard drives vary a bit more, especially now that we have regular ones in solid states. Just so you know, I'm running on a regular hard drive right now. I don't have a solid state put on. But hard drives, they have these kind of like these block sizes, okay? Or your file system, I should just say, between your OS and your hard drive, you have these block sizes. And those are whatever that block size is probably going to be your optimal buffer size. Commonly, from my experience, it's a good idea to have a buffer size that it's going to be a power of 2. A lot of times you can just go with 4 or 8 kilobytes. If you make your buffer too big, what happens is it writes a bunch of that data to the block, but then you have that cutoff. You say, well, we can't fit the whole buffer in there, so your OS has to make sure to get it into the next block also. If it's too small, well, then it's kind of like it puts it in, and then if it fits evenly into it, then it puts the other in, and it just means you didn't take maximum advantage of the block size. In the reality, either way can still be pretty quick, and it's probably going to be a lot faster than if you were just calling a write call for like every piece of data you want to put down. But still, it's nice if you can try to hit that sweet spot with the buffer size. So usually you can call 4 or 8 kilobytes a good size. But in reality, you pick something. If you're targeting like really specific hardware, I guess, then you can probably do it the perfect way. But if you are anticipating to be on all sorts of different kinds of computers with different mass storage devices, it's one of those things you can't expect to have it perfect for everybody. There's not really much you can do about it. Alright. Okay, so let's get started on actually writing this thing. So I'll bring in here, and we'll just open a new file here. So the first thing we're going to do, and understand some of this stuff is going to be kind of a little bit irrelevant to what you're actually doing, but we'll include some stuff here. So first, I am adding some stuff to just generate random numbers, because you have to have some kind of data to test with, since we're going to test this. So you'll want to include the necessary header files for creating random data. So you can just include the stuff of that. The C time is, we'll just use that as the basic C. I am going to use the fstream header so we can have the writing functionality. We'll use ifstream so that we can output the results of the test. Okay, we're just going to print out to a console. That's all we're going to do. You can reroute it to a file or whatever. It's not that hard. Also, we're going to make a type declaration for a file size. So that's going to be an unsigned 64 byte integer that can hold really big numbers. And that's just because we want to be able to work with a big file for this test. I'll have two kinds. We'll have a small one that's like 10 megs, and then we'll have a 10 gigabyte file. But also we're going to want to set up the buffering size. So as I said before, it is a bit of a guess in the ballpark on what your buffering size should be. In this case, we'll make it 8 kilobytes. That's not necessarily the best for your system, but it works good for mine. And even still, it's a power of 2. That's one rule you can generally accept, is whenever you pick a buffer size, make it a power of 2. Because chances are, as far I don't even know of a type of hard drive that has a block or sector size that's not a power of 2. I think that the legacy size is 512 bytes actually, but that's on old hard drives. Now that we have these, a lot of for desktops, especially desktop hard drives, the sectors or block sizes, they're a lot bigger. Anyway, so this is a size that works fine for mine though. Alright, and now we're going to define the file sizes that we'll use. We'll have them swappable. So the first file size that we'll have will be like 10 megabytes. We can just store it in, and we'll have it commented out because we're not going to actually use them both at the same time, honestly. And there, we have 10 megabytes. And then the other one will be stored in this big one because it's actually going to be 2 gigs. And it will cause an overflow. I'm just going to actually type out the amount of bytes for this one. 748. That is that is 2 gigs. All right. Whoops. My bad. All right. And then we'll just create a function to generate this. Now, an unsigned short is a 2-byte variable. Okay. We'll just have that return something. Just the max. Let's just have the max size that can be held by a 2-byte integer. This is unsigned short, so its maximum size is 65,535. Max possible size of a U16. Okay. Now moving on. Well, we got that. We're gonna have two test functions here, I guess you'd say. So we'll have, we'll make the unbuffered test, and then we'll have the buffered test, and we're just gonna focus on the creation of the buffered test. I'll show you the unbuffered test, so you don't need to sit through that. It's probably something you won't learn anything from it, so we'll be right back. Okay, so now we are back on this. I've just wrote this part here, and then this part here, the unbuffered test and the main, because those are parts we don't really want to focus on. I'm not here to show you that. We're gonna work on the buffer test, so I will work you through this step by step. Okay, so the first thing we have to do, of course, is create some of our boilerplate code. We'll create this, and you can write this wherever you want to with whatever file extension you want. This is just the one I'm using, all relevant thing. So here, though, we can just use a regular out file stream object, ofstream, however you want to call it. You don't have to use something like the C file pointer or whatever, although you could adapt this strategy to that. I'm just saying, although personally I like to use C++'s means for file input and output, so I'm using this. Next thing we need to do is create our buffer. Okay, so I'm using, I guess, an unsigned buffer. So that means all the values in this buffer, it's a byte by byte thing, okay? So I told you, see, I'm storing unsigned short. It's a 2-byte variable. With this buffer, I can not actually store anything else. Like it has to be an unsigned card. Whatever byte I store, it cannot be an integer value less than 0. And it can't go over 255. And this will actually be fine, because actually you can see here, I break it down into 2 pieces so that I can actually store these larger variables into the buffer still. So I'm just showing you, it's a good idea in my opinion to just make your buffers something that works by the byte, okay? You can use signed buffers also, just keep in mind that their maximum size will be less, so I think it's more like 127 to negative 128 is the range or something. In this case, it's 0 to 255. I don't need to worry about saving any data with values less than 0 though. Whether or not you need a signed or unsigned buffer for what you're doing is up to you. And then you can save in little endian format or big endian format, whatever. But for me, this is how you should be doing binary files anyways, okay? You don't want to just directly write something like an integer or whatever, because of sometimes the sizes of types can change. Ideally, you would also something like, for example, this shouldn't change based on your compiler. However, the only way to be really sure is if you include a header like cstd int. That will help. You need C++11 for that, but you can also get other libraries like Boost that will give you guaranteed sizes. But anyways, that's a bit out of the scope. I'm just saying you can use this buffering method and do something like this, so you can have your buffer manipulated by the byte, and you can still store large variables in that. If you want to, you can store a huge one like this, a U64 or S64, whatever, 64-bit one. Okay, so anyways, we'll come back to this, but here's our buffer size. The buffer size, as I said, is going to be 8 kilobytes. Now, one thing we have to keep in mind, so the way that the buffering works is when the buffer gets full, you have to dump it to the disk, okay? Clear it, and then you continue writing on the buffer. But that's the thing, chances are your buffer is going to be smaller than whatever you're writing. In this case, by a lot, okay? Both tests will be running. The buffer will be much smaller. It will fill up and need to be dumped many times before it had to be dumped many times before you can continue writing, or otherwise you'll exceed the buffer size and then your program will crash, obviously. So here we have the buffer index. Okay, so we'll set up a new loop. The file size might be really large, so we want our whatever we're iterating with, the integer, to not have a integer overflow, as in they can't fit whatever it is. The second test will be running, which will be the 2 gigabytes. That actually, since it goes by the size of bytes, it will need to be able to hold a pretty large number. I think U64 is the maximum size is actually a lot bigger, but then if you go down to U32, it's too small, so by quite a bit. It's a big jump in size between those two. Anyway, so we'll have our randomly generated value for the loop. So we'll generate that random number. Okay. Oh, and just specify the way I'm looping through this, though, it starts from 0, goes through the file size, but since we're writing 2-byte variables only, I'm just keeping this simple. I'm iterating by 2 bytes, okay? So that's why I have the I plus equals 2 in there. So now we're going to write to the buffer in memory. Obviously, you could do this differently. I'm just saying this is a normal way to do it. This is actually how I like to do binary files a lot. Sorry. next one in there. Equals val. Then these bitwise operators, I'm not really going to explain about it, but all I'm going to say is it breaks things down. So you go from this complex type, and you go to a byte by byte representation. When you're reading this file, which I'm not going to get into that, I'm just saying when you're reading this file, you have to reassemble it. But the cool thing is you can still just read them. Oh, 1 second. Oh, there we go. Okay, so the buffer index. Sorry. The buffer index will. Yeah. Okay. I got a brain fart at every moment. The buffer index then increments after you've done that write operation. Okay. This is your real write operation here. Okay. So you're looking at that. This is where you're storing your data, and then it's like this buffer you will dump. When we dump it is when the buffer index is full. So once it gets the buffering size limit, you want to dump it. So we have this out file here, we write it, and we have to cast it to a car array. And then the size of a buffer. Of course, we don't want a memory leak, so we delete it. You could optionally try to input like a smart pointer into this or something if you're using C++11, but we're just not going to worry about that. This is a very simple test case, and it's just not going to worry about that. And then we reallocate the buffer, of course, because otherwise, if we don't, we'll be writing to nothing, and we'll cause a crash. And of course, we have to reset the buffer index to 0. Okay. And then after this loop is all said and done, the only thing I'm going to have to say is the file size might not go evenly into this buffer size. So we have to write whatever's left over with the buffer. So we'll rewrite that. And the easy way to calculate this is you can just get the remainder of it. Okay, so just get the remainder of the file size divided by the buffering size. And that should be whatever is left over. If there is nothing left over, it doesn't hurt anything because it's 0. You're not actually going to write anything. And then we'll delete the buffer. And then, of course, we'll close the file. Alright, and we'll go ahead and build this and everything. That's kind of specific to your thing. Don't worry about how I do it. I'll be right back. Okay, so here we are back. I went ahead and compiled the program. Just to know, you probably might have noticed there was a semicolon I missed right here. I had to fix that. But anyways, I compiled the program. Just so you know, I used GCC version 5.2, so you can see the commands I used. And then I ran them. I ran the 10 megabyte test first, and then I ran the 2 gigabyte test next. And I want you to notice here, so the 10 megabyte one, the buffer time was better. It did run faster, but notice it's pretty negligible. Okay, the buffer time was faster. It did perform better, but it's one of those things. They're both feel pretty. It's negligible. Okay, they both take a little under half a second. I don't think any human being would notice the difference. So in a case like that, it's not the end of the world if you don't use something like buffering. Okay, you're not writing that much data in the first place. It's whatever. Now, when it comes to the 2 gigabyte one, though, obviously got to recognize that as a huge increase in file size. You can see the time was really different. This thing is over twice as fast. The buffer time performed it's twice as small. So that's the case when you're writing a lot of data. Then it definitely becomes worth it. That is something you don't need a timer to notice that one of these is faster. That is a big difference. One is 3/4 a minute, and the other is a third. So, anyways, this, of course, can vary for people. I can't guarantee to you. Heck, there might be a case like, for example, on this part, who knows, the buffer time might actually be worse if for you. But on a large file write, I'm willing to bet that for you the buffer time will probably be better. Obviously, it can vary. I mean, if you're using like a solid state drive and you test this, well, obviously you're gonna get way better times than I did here. Plus, I don't know, like I'm running on Linux. I don't think my swap partition or anything like that was getting in the way, but there's a lot of factors that can come into the scenario when it comes to your time. But anyways, and just some final words besides the final words I just made. This code is don't if you're kind of new or whatever and you're trying to apply this, don't take it to point blank. Okay, this is not how personally I would ever actually go about this. If I make use of file buffering and everything, for one, there are built-in function pieces in C++ that actually let you do this. Sort of. It's a bit different. You might want to reinvent the wheel, I guess. Maybe if you might have a good reason. If you do something like that though, like I have done before, because I just needed to really know what was going on and make sure it was stable. You probably want to wrap it up, like make a class like a buffering out file, a buffering in file, things like that. This is a very simple test. I'm just trying to explain a concept. I wouldn't take it too point blank. Anyways, hopefully, if you see any big flaws or something, some red flags, feel free to let me know. I'll correct for that. As I said, this isn't by no means the perfect code or anything like that. Again, I'm just trying to get a point across. Thanks, guys. Bye.